Hi, we're back. We're going to look at a fitting today. It's a rectangular duct fitting, a 90-degree branch fitting. And this particular one is a drop branch. So it's sloping down. You'll see it's flat on bottom here. That means we're going from 10 inch wide and 10 inch deep at the large end here, dropping down to 6 inches on both ends as far as the depth. So this thing is sitting dropping down on the top. So here's what it looks like, an example one, and you see that bottom is flat. Okay, and then as these triangles develop, this side slopes down here. And then this one, if we look at that view, you can see you got a slope to the far side here. So that whole top is leaning down. So we're going to develop this one. A couple things we want to look at the beginning here. And what we're going to do, it's the same as a drop elbow as far as the process. And what we're going to do is draw out a flat sheet first. And then we're going to put in some points and be able to triangulate from there from a true length diagram. So we can do a few calculations off the start here. We can first find the calculated length of this fitting here, because if we know it's 12 inches long on the flat, and we know it's dropping 4 inches, we can come in and do a Pythagoras calculation, knowing that it's 4 and 12 there, and we can calculate what this distance is on the flat. I've calculated that out already, and what we have, I'll just write it in the green here, is 12 and 5/8. So that slope is growing a little bit, right? The next part, and this comes in when we do other fittings as well, but we have to know some information about this crotch area here. We need to know how much drop has occurred by that point, because it's not necessarily what we see in a drop elbow where it's split 50% on that heel. And we, if you think back, we did a half drop. We're going to do that in the throat here. We'll split this, and this will become a half drop because we know that it's halfway. This one we don't know yet. We also need to know the length of that heel section. So when we calculate that out, we got to see a few things here. And what we know is if I draw this guy up here, that's our radius, our heel radius. 6 throat and 6 on the opening here. So that tells us we're 12 along that leg there. We also know that the whole thing here is 16. 10 plus 6. And we know that we're 6 across here. So that tells us this lower portion, if I was to drop this guy down here, square that straight down, and then come in, I know that I'm 10 here. So now I can calculate the height of where that crotch sits. And I could go and just draw the flat cheek and then measure it, but we can just calculate it, right? There's no problem with doing that. So I've calculated that out, and we have 6 and 5/8 here. Again, Pythagoras, we're just using 12 squared minus 10 squared, take the root, and that gives us this side. This triangle also gives us the ability to calculate out this heel section. Now, if we're thinking about calculating for an arc length, we know that we need a diameter. It's always going to be pi times diameter circumference. And a portion of that, we need some sort of angle to it. So I need the angle of this arc to be able to calculate the length of it. And now that I have this triangle, I can calculate this angle inside here. And if I can calculate this angle, I can take 90 minus this angle to come up with the angle that I need for the heel. Okay, don't forget to minus that off 90, because this isn't the actual angle of the heel, but it's the leftover off 90. Okay, so make sure you do that when you do that calculation. Now, just to note here, I got no seams on here. S and drive or whatever your seams are, it changes everything. We know that we'd have to shorten our throat and do all those rules. This length would change, things like that. But the process of the layout is what we're looking at here. So we're going to focus on that with no seams. Okay, so let's throw out our flat cheek and get out on our layout here. Okay, so there's our flat layout, and so like I said, what we're going to do is we're going to find a few things out here, and we've already done some of our calculations that we're going to use now. Now we know that this leg here is 12 inches, okay, and we know that the height here is 12 5/8. And what we have to do is find, if we compare those, what's the percentage of length taken up to get to this crotch area. So if we go 6 5/8, what percentage out of the whole 12 is that? Okay, so it's 6 5/8 divided by 12 gives us a percentage, and that's the percentage of length of the total fitting. Okay, and what we get there is 55%. So we've gone 55% of this length here, okay? What that transfers to is if we've gone 55% of the length, we've done 55% of the drop as well. Okay, so we're going to calculate that out to see how much drop has occurred at this point here. So 4 times 2 1/4. So let me label that here. So we know that 2 1/4 inches have occurred by this point. Okay? If we go around, we know that 4 inches has occurred by the ends, because that's the total drop. Okay? If I bisect in on this one, and we know 0's on this end and 2 inches at this point. So 0 drop at the start. I've got the full drop by the end of the fitting. 2 1/4 at this point here. Okay, and then half drop on the throat. The last point we need is the center of the remainder of this heel. We want to split that in half because it's too far to go here. It's too big of a triangle. So let's use some geometric construction, and we'll bisect that arc to find center. Okay, so there's my center of the remainder. It's not half the arc like it is here, half the throat, half the heel. It's half of what's left over, half of the actual heel, not half of 90 degrees. Okay, so let me just clean my lines off there. If we knew we were 2 1/4 drop by this point, that gives us 1 3/4 left to here. And if we divide that in half, we know that we're going half the remainder drop by this point, and then the other half by the next point there. 2 15/16. So now I have all the drops associated with everywhere I need a location or a point on the drawing here. I could draw in a bunch of triangles here now to give me element lines to triangulate. Now the other benefit of the way I've labeled it, of the amount of drop we have, is as we label in our element lines, you'll see that we'll go 0 to 2 1/4, and it's the difference between the two numbers we've labeled with that's going to give us the actual drop in that point. It's kind of like difference in profile, but if we're dropping 2 15/16 here, and 2 inches here, that means the slope between those 2 points is 15/16. And that's what I'm going to have to put into a true length diagram, is the difference between any of these points. And because they change, we can't just say it's a half drop or like a 1 inch drop, a 2 inch drop, something like that. It changes throughout the whole fitting. Okay, so now that I have that, let's get some triangles drawn in and some labeling done. So let's label A, B, C, D, E, F, G. And let's draw in all those element lines to connect that like we have in the elbow. Okay, so now I have all my element lines drawn in. I'm going to triangulate this just like I would on a drop elbow, just on the 90. I'm going to start at baseline AB, triangulate C, and then just keep stacking triangles one another until I get to the end at FG. So let me get this out of the way and we'll start that off. One thing again before we do is remember our fitting is flat on bottom. So we've drawn the bottom flat to the inside. When I draw the top now, I'm going to flip it so that I'm looking at the inside. So my branch is going to go over this way instead of going to the right. Okay? Okay, so I've got baseline AB, I've flipped it over, I've created a true length diagram, and now I'm going to work all my pieces together. Now, what I can do off the start, and I like to, is I know that I'm going a 2 1/4 drop here. I know that from CD I'm going a 1/4 inch is the difference, and then 15/16 is the difference, and then 1 1/16 is the difference. I can put all those numbers into my true length diagram before I get started. Okay, so let's do that. So let's start triangulating that fitting now. So take the length of AC. Now that has from 0 to 2 1/4 as our 2 1/4 inch drop, and that one, that's this top one. From A. Take BC. And again, the 2 1/4 from B. And there's point C. Okay, BD. There's one we didn't get on there. It's a 2 inch drop. Last line to finish us off is FG, and that's a true length in here. That's our 6 inch leg. And that's point G. Clean up some marks there. Okay, so that's all our points triangulated. Let me go in and fill some of those lines in.
Okay, so there's my branch portion completed. You can see I'm off 90, which is expected because it's dropping. Now when we make this fitting, all of these aren't going to be kink lines. It won't be kink like we see here. We'll just do the same kinks that we did on drop elbow. We're going to have one kink here and one across this way to flatten it. So we only want two. And that's to bring it down for the first one and then to flatten it back out for the second one. Okay, so now we can finish off this portion of it. And we knew we calculated that to 12 5/8 as a linear measurement. So from point A, I just square that up. Come over my 6. And that should land perfectly at our crotch here as well. Okay, so when we triangulate point C, we still want to hit perfect here from this straight portion of our branch as well, because it remains at 6 inches here. It has to. So we don't want those misaligning somehow. If those don't line up, that tells us something's wrong. If point C is off there. Okay, 90-degree drop branch.